consider random variable x such that x is distributed binomially with parameters n and probability is 0.25. Determine the least value of n such that probability that x is greater or equal than 1 is greater than 0.99. It's quite a typical question, and the first step, we should rewrite this probability as we know that probability of wanted events is equal to what? 1 minus the probability of what? Unwanted events. And if we need x to be greater or equal than 1, unwanted is what? X to be equal to 0, just x to be equal to 0. So we can rewrite as 1 or probability that x is greater or equal than 1 is equal to 1 minus probability that. In general, it's less or equal, but since there is only x is 0, so we can write that it's just x is equal to 0. In general, if, for example, x is greater or equal than 10, it's what? 1 minus probability that x is less or equal than 9, because we need 10 or greater, so unwanted values are 9 and less. And it must be what? Greater than 0.99. And just rearrange for p. So if we move it to the right, it becomes less, not greater, because you can see p becomes here, and with respect to p becomes less than what? 1 minus 0.99, which is what? 0.01. Or if you move 1 to the right, it becomes negative p. Negative probability is greater than something, but you remember, for inequalities, if you multiply or divide by negative value, you should flip this inequality sign. So it becomes negative p is greater, so p will be less. And what is probability for binomial? In general, there exists a formula for binomial, but it can be solved without a formula, and formula is not given in a data booklet. So what does it mean? Probability is that x is 0. It means that we need what? Number of wanted events is 0. And what does it mean? That all n events are unwanted, and probability of unwanted event is what? It's 1 minus p, or 0.75. So, and notice that there are n items or n events, and probability x to be equal to 0, it means that probability of wanted events and probability of wanted event is 0.25, and it means that all n events are unwanted with probability 0.75. But since all items are the same, there are no permutations, and we don't need any binomial formula, because actually binomial formula takes into account all possible permutations or something like that. But when events are undistinguishable, events are the same, or objects are the same, or something like that. For example, all balls are red. For example, if you need 5 balls, 4 red, 1 green, green may be the first on the first place, on the second, something like that. So there are some permutations. Here there are no permutations. So finally, all, it becomes 0.75 to the power of n, and it should be less than 0.01, and we should just solve this inequality. You may consider just to be equal, and the first way is what? Use the graph using a calculator, or use some tables or something like that, but we can solve it without without graph or table. How? Use since it's exponential inequality equation, to move or to remove this exponent as unknown, we should do what? We should apply what? Logarithm to any base, for example ln, and we apply ln on both sides. So we write ln. In general, it may be log to any base. ln less than ln of 0, 0, 1. And according to the property of logs, this power moves in front of ln. So it becomes just n multiplied by ln is less than ln. But ln it's just a number, and it is also a number. But if you keep inequality, notice that ln of 0.75, it's negative value, and if you divide by negative value, so to get just n, we divide both sides by ln of 0.75, but it's negative, so we should flip the inequality sign. And we get that n is greater than something, and this something is ln of 0.01 divided by answer to get 16 point something. And since n is integer, you need the first integer, and you round not mathematically, you round not to 16, you round up, because we need n to be greater than this value, but n is integer, so n is 17. So the least possible value of n is 17. And if you use equality, it will be the same. You do ln, it will ln, and n moves so here in front, and ln of 0, 0, 1, and you get the same. It's much easier. You don't need inequality, but you get again n is 16 point something, but you should understand that here function is decreasing. Why decreasing? Because we consider function was 0.75 to the power 1, and one value or number which is less than 1 is multiplied by itself. The result is less than the value. For example, 0.75 multiplied by 0.75, it will be less than 0.75, so it's decreasing function. So it's some decreasing function, and value when it is equal to 0.01 is 16 point something, but n should be integer, and we need value of a function should be less than, so we round up because we need value to be less than, below this point, so we round up to 17. So the least possible value of n is 17. It's because function is decreasing. For another problem, when function is increasing, there may be questions, so that you should round to below or up. It depends on the problem. But if you do inequality, you get directly, then you need n to be greater, and n is integer, so you just round up to the first integer. But you should Remember that ln can be negative, and if you divide by negative value, you should flip the inequality sign. So n is 17, and that's all for this question.